Problem number 1. For the 3-branch piping system shown in figure 11.4, we have the following data. Determine the flow rates Q and the piezometric head H at the junction. Assume constant friction factors. The dimension of the pipes are listed on the table.
So for the question number 1, first, we need to find the head loss on each pipe. So the formula that I use is by adding the major loss and the minor loss. So HF is equal to FL B squared over D times 2G plus K B squared over 2G. And since B squared over 2G is also equal to 8Q squared over pi squared times G times D raised to 4. Now the equation that we get is HF is equal to FL over D plus K multiplied by 8Q squared over pi squared G times D raised to 4. And by substituting all the given properties on each pipe, so HF sub 1 is equal to 0.025 times 500 divided by 0.10 plus 3 multiplied by 8Q sub 1 squared divided by pi squared multiplied by 9.81 multiplied by 0.10 raised to 4. So HF sub 1 is equal to 105,762.3772 Q sub 1 squared. And now for HF sub 2, it is equal to 16647.7816 Q sub 2 squared. While for HF sub 3, it is equal to 42081.9641 Q sub 3 squared. So now, in this slide, since we need to determine the flow on each pipe and also the elevation of piezometer H, first we need to express the piezometer H as an X, and by doing that, we can get the difference in elevation of each head loss. So for the elevation of head loss 1, it is equal to X minus 5. For head loss 2, it is equal to 20 minus X, and for head loss 3, it is equal to X minus 13. Since we already got the difference of elevation in each head loss, now we can find the equation of the flow in each pipe. So for Q sub 1, it is equal to 3.0749 times 10 raised to negative 3 multiplied by square root of X minus 5. For Q sub 2, it is equal to 7.7504 times 10 raised to negative 3 multiplied by square root of 20 minus X. And for Q sub 3, it is equal to 4.8748 times 10 raised to negative 3 multiplied by square root of X minus 13. Q sub 2 is equal to Q sub 1 plus Q sub 3 is the equation at the junction. So by substituting the equations we got in the previous slide, we can now find the value of X. So 7.7504 times 10 raised to negative 3 multiplied by square root of 20 minus X is equal to 3.0749 times 10 raised to negative 3 multiplied by square root of X minus 5 plus 4.8748 times 10 raised to negative 3 multiplied by square root of X minus 13. So by dividing it by 7.7504 times 10 raised to negative 3, we will get an answer of square root of 20 minus X is equal to 0.3967 multiplied by square root of X minus 5 plus 0.6290 multiplied by square root of X minus 13. So by squaring both sides, we got 20 minus X is equal to 0.1574 multiplied by X minus 5 plus 0.499 multiplied by square root of X minus 5 multiplied by square root of X minus 13 plus 0.3956 multiplied by X minus 13. We get an answer of negative 1.553 times x plus 25.9298 is equal to 0.499 multiplied by square root of x minus 5 multiplied by square root of x minus 13. And by squaring both sides again, we will get an equation of 2.4118x squared minus 80.5380x plus 672.3545 is equal to 0.249 times x squared minus 18x plus 65. And now we can get the value of x. So for the first value of x is equal to 20 meters and the second is 15.2 meters. But since x is less than 20 meters but greater than 13 meters, so the final answer for the elevation of piezometer is equal to 15.2 meters. So since we got the value of x, which is 15.2 meters, and by substituting it to the previous equations, q sub 1 is equal to 3.0749 times 10 raised to negative 3 multiplied by square root of x, which is 15.2 meters minus 5, and the final answer is 0.098 meter cube per second. And for q sub 2, 7.7504 times 10 raised to negative 3 multiplied by square root of 20 minus 15.2. The final answer is 0.0170 meter cube per second. And lastly, for the q sub 3, 4.8748 times 10 raised to negative 3 multiplied by square root of 15.2 minus 13, and the final answer is 0.072 meter cube per second.
Problem number 2. For the system shown, determine the flow distribution of water and the piezometric head H at the junction. The fluid power input by the pump is constant, equal to 20 kilowatts. Assume constant friction factors. The dimension of the pipes are listed on the table.
For number 2 solution, we need to get the equation for the combined flow rate. Q sub 1 minus Q sub 2 minus Q sub 3 is equals to 0. Therefore, our combined flow rate equation is equals to Q sub 1 equals Q sub 2 plus Q sub 3. After which, we need to express the head loss in terms of X. The head loss for the pressure plus the head loss for pipe number 1 is equals to X minus 10. For pipe number 2, the head loss is equals to 30 minus X. Lastly, for pipe number 3, the head loss equation is equals to X minus 15. In using Darcy-Weisbach or Manning formula, head loss varies with flow rate. Head loss is equals to minor loss times flow rate. Head loss is now equals to X. X is equals to minor loss times flow rate. So for our equation number 1, flow rate is equals to minor loss square root of X minus 10. Or flow rate is equals to 2 square root of X minus 10. For the equation number 2, we have flow rate is equals to 1 square root of 30 minus X. And lastly, for our equation number 3, flow rate is equals to 1 square root of X minus 15. Now we are going to solve for X using the combined flow rate we have mentioned earlier. Flow rate 1 squared is equals to flow rate 2 squared plus flow rate 3 squared. For the equation, 2 square root of X minus 10 is equals to square root of 30 minus X plus square root of X minus 15. Using different algebraic methods, we are going to arrive in an equation of 16x squared minus 440x plus 3025 is equals to negative 4x squared plus 60x minus 180. As we simplify the equation, we are going to arrive in a quadratic equation of 12x squared minus 500x plus 4,825 is equals to 0. Using our shift solve in our calculators, x is now equals to 15.1813. We are going to solve for the headless. Headless is equals to 0.0826 times friction times the length times the flow rate squared over the diameter raised to 5, which will be equivalent to x minus 10 equals to 0.0826 times friction times the length times the flow rate squared over diameter raised to 5. Now we are going to evaluate the flow rate for each pipe using the x we have solved earlier. For flow rate 1, 15.1813 minus 10 is equals to 0.0826 times 0.02 times 50. Flow rate squared is equals to 0.15 raised to 5 equals to 0.069 meter cube per seconds or 69 liters per second. The same process for flow rate 2 and flow rate 3. The answer for flow rate 2 is equals to 0.035 meter cube second or equivalent to 35 liters per second. For flow rate 3, it is equals to 0.017 meter cube per seconds or equals to 1.71 liters per second. For finalization of our answers, x is equals to 15.1813 meters. For flow rate 1 is equals to 69 liters per second. Flow rate 2 is equals to 35 liters per second. And lastly, flow rate 3 is equals to 1.71 liters per second. Thank you very much.